All right. So the next lesson is operations with complex numbers. So now you're going to learn how to add, subtract, multiply, and divide with complex numbers. Okay, so remember that a complex number is in the form a plus bi. This is the real part. A is real, b is the imaginary part. Okay, so when I combine them by adding or subtracting, I can only add real components together and imaginary components together. Okay, so here's our first example. Okay, if I give you 3 plus 2i minus 1 minus 6i. Okay, so this right here is one number. This is a plus bi. Okay, this right here is another number, a plus bi. So I'm subtracting these two numbers. All right, so just like I would with any other problem, the subtraction right here, I'm going to have to distribute that to each of those terms. So because this is one number, I can actually drop the parentheses at this point because those parentheses are just telling me that this is one complex number. This parentheses are just telling me this is another complex number. Okay, and now I'm getting ready to subtract. So I'm going to drop the parentheses from the first number. I'm going to distribute this negative. So this is going to become negative 1 plus 6i. Okay, negative times negative is positive. And now I combine the real and the imaginary components together. So 3 is real, negative 1 is real. So 3 minus 1 is 2. And then 2i is imaginary, 6i is imaginary, and 2i plus 6i is 8i. Okay, so when we are adding or subtracting, all we do is combine like terms, basically. Okay, so here's another one. 4 plus 3, 4i plus 3 minus 6 plus I minus 1. So here, there aren't any parentheses, nothing's being separated, okay, but it's still the same thing. I'm adding and I'm subtracting, so I just add the real components and the imaginary. So 3 minus 6 minus 1 is going to give me negative 4. And then 4i and plus I is 5i. Okay, now very important that you understand that this answer has to be written in a plus bi form. So if you were to write this as 5i minus 4, this would be wrong. Okay, it has to be written in that order. All right, that's adding and subtracting, easy peasy. Now, what happens when we multiply? All right, so when we multiply complex numbers, it can look something like this. 5i times 3 minus 2i. Okay, so I'm going to distribute here. I'm distributing an imaginary number, but the I is kind of treated like an X. So when I multiply 5i times 3, I'm going to get 15i. When I multiply 5i times negative 2i, I'm going to get negative 10i squared. So just like if this was 5x and 2x, the x times the x will give me x squared. I do that with the I squared as well. Now, based off of last lesson, okay, remember that every power of I is equal to something else. So in this case, I squared is really equal to negative 1. So I'm going to substitute that in. Now it's important to understand this is negative 10 times I squared. So when I substitute that negative 1 in, this is going to become negative 10 times negative 1. Okay, so this is what's replacing the I squared. So I'm going to have 15I plus 10, but then because this is not in the correct form, I actually have to flip this around, 10 plus 15i, and now it's in the a plus bi form. Okay, so when we multiply, we're going to generate other powers of I, and that's why we have to remember that all of the powers of I are equal to something else, so we can substitute and simplify. All right, here's our next example. Okay, we can also double distribute complex numbers, something like this. 5 plus 3i times 2 minus 3i. Mommy? All right, sorry, Carver was bugging. Okay, so now if I'm multiplying two complex numbers, you can see this is a plus bi. There's 1, okay, a plus bi, there's 2. I double distribute just like I would with x's, okay, or variables. So, there we go, all right. Okay, so we're going to double distribute. 5 times 2 is 10. 5 times negative 3i is negative 15i. 3i times 2 is 6i. and 3i times negative 3i is negative 9i squared. Okay, so we're going to combine like terms. This is a 10. All right, so the 10 is going to stay. These two are like terms. Negative 15 plus 6 is negative 9i. And then I have minus 9i squared. Now, just like on the last problem, remember that I squared is actually equal to negative 1. So that has to be simplified. You should never have a power of I greater than 1 in a problem. So having this I is fine, but if I have an I squared or an I cubed, something like that, it has to be simplified down. Okay, so we're going to plug in that negative 1. It's going to be 10 minus 9i minus 9 times negative 1. Remember, these are being multiplied, so that's going to be multiplied. So this becomes 10 minus 9i plus 9. And now I have another real number, and that's going to combine with the 10 and give me 19 minus 9i. And that is my answer because it is in a plus bi form. All right. So what happens when I multiply something that looks like this? 2 plus I times 2 minus I. Okay, so we have two complex numbers. We are multiplying again. Okay, the parentheses are touching. There's nothing in between. So we're going to double distribute. Okay, 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is 2i. And negative I times I is negative I squared. Okay, same thing here. We combine those like terms. Well, this is negative 2i plus 2i, so those actually go away. And so I'm just left with 4 minus I squared, but I squared is equal to negative 1. So this becomes 4 minus a negative 1, which is going to turn into 4 plus 1, which is equal to 5. So notice here that my answer is a real number. I multiplied two complex numbers, but I got a real number. Okay, well, part of that is because if you look back at this problem, do you see that these numbers are practically the same except for the sign in between? Okay, so that first number is a plus bi. That second number is a minus bi. Whenever I have two numbers that look like this, where they're identical except for the sign in between, these are called complex conjugates. Okay, and anytime I multiply them together, my answer is going to be a real number. Okay, when I multiply only. Okay, so here is another example. 3 plus 2i, that's supposed to be parentheses, times 3 minus 2i. Okay, so we double distribute. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. And 2i times negative 2i is negative 4i squared. Okay, so when we combine like terms, the 9 is going to stay. Again, you should see that these two pieces cancel each other out. Okay, and then I have minus 4i squared. But remember, what is I squared equal to? Negative 1. So this is going to become 9 minus 4 times negative 1, which becomes 9 plus 4, which is equal to 13. Okay, so if I multiply two complex conjugates, my answer is going to be a real number. It makes the imaginary component cancel out. So these two imaginary pieces will cancel. That I squared will be substituted with a negative 1, and so this generates a real number. This is important for when we divide.